Welcome dear students. Our today's topic is the photoelectric effect. This topic belongs to the chapter atomic structure. My dear students, let us first talk about the introduction of the photoelectric effect. The word photo, it means light, and electric word means electron. So this topic is about the light and electron. My dear students, simply we can say when light hits a piece of metal, then some electrons are ejected from that piece of metal. And this phenomena of the ejection of electrons from a piece of metal when the light hits its surface, that is called as the photoelectric effect. The electrons which are removed from the piece of metal, they are called as photoelectrons, and the photoelectrons produce a current when they flow in a closed circuit. That current is called as the photoelectric current. Now, my dear students, we have said that when light hits the piece of metal, electrons are removed. The process of ejection of electrons from the surface of metal when the light hits its surface, that process is called as the photoemission. So, photoemission is the process of emission of electrons from the surface of metal when light hits the surface. My dear students, now let us talk about that how this photo emission takes place. I have drawn two atoms. This atom belongs to metal A, this atom belongs to metal B. This one is the nucleus of both atoms, and this green shows the electron in the valence shell. Now, my dear students, this red line between the electron and nucleus is showing basically nuclear force of attraction. As nucleus is positively charged and electrons are negatively charged, so there is a force of attraction that binds the electron with nucleus. When light hits this valence electron, the electron can be knocked out only if the light has energy to break this nuclear force of attraction. The light must have sufficient energy to break the nuclear force of attraction, and once the nuclear force of attraction is broken down, the electrons are ejected from the metal atoms. Now, that minimum energy that light must possess to break the nuclear attraction and eject the electron from the valence shell, that energy is called as the threshold energy. Threshold energy is the minimum energy that light must possess to break the nuclear force of attraction and remove the electron from the valence shell of the atom. This threshold energy is also called as work function, which is represented with this symbol. In Greek language, it is phi, and it is one of the Greek alphabets. Now, energy, frequency, and wavelength, these are three properties of the light. So, the minimum energy required, that will be called as threshold energy, and the minimum frequency required will be called as threshold frequency, and the minimum wavelength required will be called as the threshold wavelength. If the light has energy less than threshold energy, then that light will not be able to break the nuclear attraction and remove the electron, so there will be no photoemission and no photoelectric effect. So that is threshold energy, threshold frequency, and threshold wavelength. Now, my dear students, every metal has its own atomic size. Depending upon the atomic size, the nuclear attraction on the electrons is different in case of every metal. So, in order to break the nuclear attraction, the different threshold energy and the threshold frequency of light will be required in different metals, as different metals have different atomic sizes and different magnitude of the nuclear force of attraction. So you can say that the work function or the threshold energy, that is the characteristic feature of every metal, and it varies from metal to metal. Now, why we use only metals in the photoelectric effect? Because the metals, they have low ionization energy. And the metals, when they have low ionization energy, it simply means that the electrons can be easily removed from the metal atoms. And especially those metals are used that have sufficiently low ionization energy, like potassium, rubidium, cesium. They are alkali metals, and alkali metals are among those metals of the periodic table that have lowest ionization energy. And among alkali metals, these three metals, because they are present at the bottom of the group, so because of their larger size, their ionization energy are among the lowest. So that's why we use these metals in the photoelectric effect. Now, my dear students, non-metals cannot be used. Why? Because non-metals, they have very high ionization energy, and the light that will be required to remove the electron, that will also be having, that should be having very high threshold energy and high threshold frequency and low threshold wavelength. So usually non-metals are not used because a very energetic light is required to emit the electrons or to eject the electrons from the metals of, from the atoms of the non-metals. Now, my dear students, what is the principle of photoelectric effect? The principle is very simple. It is the law of conservation of energy. And according to law of conservation of energy, energy can neither be created nor it can be destroyed, but it can be changed from one form to the other form. So now we will look that how this energy of the light is transferred to the electrons. There is a relation that energy of light is equal to threshold energy, which is also called as the work function, plus kinetic energy of the electron. And this kinetic energy will be basically the maximum kinetic energy of electron. So simply saying, this energy of the light is used as the threshold energy to break the intermolecular forces and remove the electron, and the remaining energy of the light is transferred as kinetic energy of the electron. We can also write it as E light is equal to threshold energy, is also called as work function, plus kinetic energy is half me into v square. Here me is the mass of electron, and you know that is 9.1 into 10 raised to power minus 31 kilograms. So here, for a single metal, this wave function will be, work function will be fixed. Similarly, mass of electron is fixed. It means energy of the light and velocity of the electron, they have direct relation with each other. Mean, the more energetic the light will be, the greater will be the speed of the ejected electrons. So they have direct relation with each other. My dear students, looking at this relation, now we can conclude that if the energy of light is less than work function or threshold energy, then that light will not be able to break the nuclear attraction and eject the electron. So there will be no photo emission in that case. If the energy of light is equal to the threshold energy, then the nuclear attraction will be broken down, an electron will be ejected from the metal, but the half mv square, because both these will be equal, E and Q both are equal, so half mv square will be equal to 0. Kinetic energy of the electron will be equal to 0. Now this formula is just rearranged form of this formula. And if the energy of incident light, that is greater than the threshold energy, then my dear students, photo emission will take place, and the extra energy possessed by the light, that will be transferred to electron as its kinetic energy. So these are the three cases: whether the light energy is less than threshold energy, equal to threshold energy, or greater than threshold energy. Summarizing this, we can say if less, then no photoemission. If equal, then there will be photoemission, but kinetic energy of electron will be zero. And if it will be greater, then photoemission and the extra energy will be transferred as kinetic energy to the electron. Now, what are the characteristics of photoelectric effect? This is a very important point because lots of concepts are there. Characteristics first, no time lag. Mean as the light will hit the electron, immediately the electron will be ejected from the metal atom. There will be no time lag. Photoelectric effect is an instantaneous process. Second, intensity of light. Intensity of light means number of photons in the light. So greater the intensity of light means greater will be the number of photons in that light, brighter that light will be. And when the number of photons will be greater, then obviously there will be more electrons that will be emitted from the metal atom and more photo emission will be seen and number of photoelectrons that will be very large. I have just used the term photon. What that term means, I will explain it just after some time in this lecture. So greater the intensity of light, more will be photo emission. Intensity of light is directly proportional to photo emission. It means the number of photoelectrons will be larger. And if the frequency of light will be greater, obviously frequency and energy both are though both can be written interchangeably. If the frequency will be greater, then the electrons that will be ejected from the metal atom, they will be having more kinetic energy because some of the energy of that light will be used to break the to break the nuclear force of attraction, and the remaining energy will be stored as kinetic energy of the electron. So if you are using more brighter lights, then there will be more number of photoelectrons that will be ejected from the metal and more photoelectric current will be produced. But there will be no effect on kinetic energy of electron. But if you will be using the light with higher frequency, then the ejected electrons will be having more kinetic energy, but the number of photoelectrons that will not be affected. So these are the three very important concepts. Now listen very carefully. I have just mentioned here that photoelectric effect is an instantaneous process. There is no time lag in this process. How we can explain this? Einstein contributed to explain this phenomena because according to the classical laws of physics, the light moves in the form of wave and it continuously propagates energy, and it only shows wave like properties just like diffraction, refraction, reflection, etc. So according to the classical laws of physics, light propagates continuously and it shows only wave like properties. If the light shows only wave like properties and it propagates in a continuous manner, then this light should hit the electrons, and first electron should absorb some energy, and after absorption the electron must be ejected from the metal atom. It means that when the light is in continuous form, then first electron will absorb some energy, and then after absorption of energy it should be removed from the metal atom. So there will be some time lag between the absorption of energy and ejection of electron. Photoelectric effect according to classical laws of physics, considering the light just as a wave, that is not possible to be instantaneous. There must be some time lag. But in actual, there is no time lag, and photoelectric effect is an instantaneous process. How can we explain this? Actually, in 1900, Max Planck proposed the Planck's quantum theory, according to which he said that light, just like other electromagnetic radiation, does not have a continuous propagation, but it moves in this continuous manner in the form of small energy packets, and those small energy packets are called as photons. So the Max Planck in 1900, he already proposed the idea of the photons and the discrete energy packets of the light. In 1905, Einstein used this idea of the Max Planck, and he explained that actually the light is not propagated in continuous manner, whether the light, instead the light moves in the form of small discrete energy packets, and when these energy packets they hit the electrons, then immediately the energy packets energy or the photons energy is transferred to the electron, and without any time lag the electron is ejected from the metal atom. So Einstein basically used the concept of Max Planck and explained that in photoelectric effect there is no time lag, just because the light is not moving in continuous manner, and the electron is not first absorbing the energy and then is being ejected from the metal atom. Rather, the light is moving in the form of small energy packets, and when this energy packet hits the electron, immediately the energy of this photon is transferred to electron, and without any time lag the electron is ejected from the metal atom. So that's why there is no time lag in the photoelectric effect. And now this was the dawn of some modern sciences, because now it was proved that the light is not just a wave, rather it shows dual nature. Light shows wave-like properties like reflection, refraction, diffraction, and on the other hand, light consists of small discrete particles, photons, so that also shows the particle-like property, and photoelectric effect is one of the practical example of the dual nature of the light, and it is one of the example of the case in which the light behaves as small particles, as light behaves that it consists of the small particles. And because of these findings of the Einstein and explanation of the no time lag in the photoelectric effect on the basis of the photons of the light, the Einstein was awarded a Nobel Prize in 1921. And Einstein also used the Planck's equation E is equal to h mu to relate the threshold energy, threshold frequency, and threshold wavelength. So E is equal to h mu, it means threshold energy is equal to h into threshold frequency. So greater the threshold frequency, more will be the threshold energy. Similarly, threshold frequency is related to threshold wavelength in the form of C over lambda, and threshold energy is also related to threshold wavelength in this relationship. So he also developed the relationship between the threshold energy, threshold frequency, and threshold wavelength. Here h is the Planck's constant, has value 6.626 into 10 raised per minus 34 joule second. C is the speed of light, 3 into 10 raised per 8 meter per second. Now, my dear student, we have repeatedly used the term photon after this Einstein's contribution. Now, let's see what the photon means. Photons are basically small energy packets, and those energy packets they have all quantum number value 0. Their principal quantum number is 0, azimuthal quantum number is 0, magnetic quantum number is 0, and spin quantum number is 0. So all quantum number for photon that are 0. Secondly, photons are massless, they are chargeless. So that's why they are neither affected by electric field or magnetic field. Electric field and magnetic field both have no effect on photons. And in vacuum, they travel with the speed of light. This one is their speed when they are traveling in the vacuum. So photons are basically the small energy packets. Now let us move towards the experimental study of the photoelectric effect. This one is a vacuum tube having a metal piece and a detector. There is an emitter, and this one is the battery, and the voltage can be adjusted according to our desire from this battery. Now this metal is M, this one is the detector. The metal piece is connected to the negative terminal of the battery, so it will be acting as cathode, and the detector is connected through emitter to the positive terminal of the battery, and that will be acting as anode. When the light falls on this piece of metal, then the photo emission takes place. Electrons are removed from this piece of metal, and these electrons, they move from negatively charged plate towards this positive detector, which is anode. So electron, they start traveling as they are being repelled by this negative plate and attracted by the positive detector. The detector is also called as the electron collector. So when the electron will move in this tube, then the photoelectric current will be produced, and these emitted electrons will be photoelectrons. The process of emission will be photoemission, and the current that flows through this tube, that will be called as the photoelectric current. This detector, it collects the photoelectrons, and it also determines the kinetic energy of the photoelectrons. So this was the experimental study, and an experiment was performed to have a practical demonstration of the photoelectric effect. Last, what are the applications of the photoelectric effect? My dear students, the solar panels that are used in your houses, they receive the light energy from sun, and then through photo emission, the electrons are produced, current flows, and that current is stored in battery. And then on need, that current is used. So there are lots of applications of the photoelectric effect in daily life. One of the very famous and familiar example I have quoted here. The rest you can study from the different books. So that was all about the photoelectric effect with respect to the atomic structure. The photoelectric effect that we have discussed here, that is related to the atomic structure, which is the chapter of the chemistry. So the discussion was purely related to chemistry. Some of the graphs or other information that is included in the physics, but as far as the chemistry is concerned, this was all about the photoelectric effect. See you in some other video lecture. Till then, take care.